Yeah, thanks for the introduction. So, yeah, I did a conference to accept my own talk. That feels cheating, but now you're here, so you're trapped to watch me for 35 minutes. So, yeah, I'm going to talk about universal React in OCaml. I'm going to explain what's universal, what's React, and why in OCaml. Before, I worked for Ahrefs. Ahrefs is a SEO company. We crawl the internet, very massive data, and then SEO people, marketing people, like check on our tools a lot of metrics. So you can imagine that we have like a lot of tools for different like reports. So for example, Content Explorer or Site Explorer, Site Audit, or Keyword Explorer. Like people can like spend their own entire life here, and they can optimize their website, make millions for themselves, make millions for others. So that's why people use our product. You can imagine how every tool is kind of like a vertical, and some tools are shared, but some others are completely separate. Today I want to talk about how we get, like our front end is massive. I think there's like 5,000 components or 5,000 front end files, and it's different on different kind of domains. And we're in a world where we render everything on the client. It's a website, of course. People visit it, keep it open forever. So there's a few different things from other applications. But at the end of the day, we are a SaaS application. So before further ado, I'm David Sancho. I work from Barcelona. And yeah, I'm software engineer for Ahrefs. The index for today is a little introduction on what's React. Then what's universal code, because it's a very not super fan of the word, but yeah, how we made it work, and then some future plans that we have, right? So at the beginning of it, it's like what's a React component? A React component, how we define it in Reason or Reason React is you have like a little function make and then the annotation, like the PPX attribute, and that creates a React component. If you use Melange, it gets compiled into like the minimum JavaScript possible, and it's bind to React, or in this case, the JSX runtime. Doesn't matter. At the end, this gets bundled and inserted in a web page. This web page, when the user visits, it renders the high component. So that's how the minimum definition of what's a React component. In the server-side environment, it's a little bit different. So you provide a route that's up to a framework or whatever, but then you render to static markup. Once you visit this website, the HTML result needs to be returned as a string. So one way is you render, you run JavaScript, and the other one is you output a string. If you look at the network stack, you compare both. You see when HTML is downloading, then you have like a some script that loads after the browser catches them, and then it executes the JavaScript. So what actually happens on a client-side rendering, the web page is empty until the JavaScript runs. So the user would wait for seconds, multiple seconds, until the JavaScript loads, and then you see the application build up. On the server-side side, it's a little bit different, right? Like the HTML contains the content of the website. It contains the content without the interaction. So you see that the content loads instantly, or like at least way before than the client-side rendering, right? The fun thing is that you can use React to compose like all this hierarchy of the tree. This is just a random example of our code base. And you can configure everything, like set up all the boxes, UIs, kind of like the front-end part, and it composes very nicely to at the end get rendered on the server. Server-side rendering is a technique that it's used mostly for user experience, right? People would use server-side rendering to make SEO happy, but SEO is just a proxy for user experience. So it loads faster, you get the content easy to the users, you have accessibility because the content loads first, and it's bare overall. Of course, there's downsides. I'm not going to talk about those, but the idea is that we want server-side rendering in Ahrefs because we have a lot of tools that load a lot of data. So as soon as we have this data on their face, it's bare. Of course, I'm talking mostly about like the dashboard, like the kind of application, but there's as well public sites, there's well like internal tools. So there's other places where we can benefit a lot from server-side rendering. If we go back to React, I really love this slide. I mean, I made the slides, no? But I really love this piece of code where it defines what's the minimum model of React. React allows you to create these trees, and I think it composes nicely with a variant. You have lowercase element, which is like a deep, span, h1, h2, an uppercase component, which is like a function that returns an element. So here's where the recursion happens. You have synchronous component, so when you have an element that depends on a promise. So here's how how internally React composes all the structure I choose before, right? Explained before. And there's other parts that are very specific to React that doesn't really matter here. What we did at Ahrefs is we re-implemented this part from the server. So React has a JavaScript implementation that works in the browser and works on Node.js or any JavaScript engine on the backend. We re-implemented the backend part. So we took this model and we implemented 3 different functions from React DOM, it's called. So you can output the string are you used to on JavaScript, but we did on OCaml. The resultant part this is an example of a demo. So the first instant load, you have the header already there, and then the whole client loads when the JavaScript finishes parsing and executing, right? We are in a point where we migrated, or we are continually migrating most of our tools into server-side rendering with this way, and there's more to come. So there's still some progress. The word universal, as I said, I'm not super fan with it, but it's the only one that I could come up with. So the idea with universal is that you have a universal React component. That's just one module on OCaml. If you compile it with Melange, with Reason React, then you have the JavaScript file. If you compile with OCaml, you have server Reason React, and then that gets the string as HTML, right? So you have like one component that is shared between both targets. The good parts of universal component is that, of course, you can share with a single language, right? That's kind of the biggest win. We have been thinking about it since Antonio tried Melange at the beginning and like very long time ago. That has been like one of my motives, mostly because when you understand one simple language, you don't need to learn 2 different paradigms. You can learn one LSP, one build system. It's more like you can onboard people way faster. You can create community. So it's more like very easy when you want to scale a big team. Of course, as well, like there's interesting benefits. So you can have like bare client-server integrations. And of course, re-implementing this in OCaml, it's because as well we have like for free a native performance. So at the end of the day, that's kind of like one of the juicy parts of OCaml that we take it for granted. But when you are, or at least myself, I have been working for JavaScript for more than 10 years, you really lack performance when you run a node on production. So every time that I explain this project and I share it with a few friends, everybody's like, okay, native performance is pretty good, but how much? Like the numbers, show me the numbers. So we compare with 2 of the most common approaches in the front-end ecosystem. That's Node and Bun, and that's an old legacy benchmark. But the idea is that we outperform them by far. Even though that's not the primary goal of the project, like we don't check performance constantly. We just want to be good at it, but not obsessed with it. On a more recent benchmark, like that's this August, I rendered just one component, which is a completely kind of really bad benchmark, but still fun to do. We were like 34 times faster than other implementations. So we still check from time to time that we're in a good path. But yeah, it's more important to share code and be universal rather than be fast. The bad part or the hard parts of making a component universal or a module universal is that these client components are meant to live on the client. So they contain a lot of browser APIs. So you can think of focus events, scroll, any sort of dependency. And as well, like they're all in OCaml, all modules from a file system need to be bound. Bound, I don't know if it's the right term, but it's like Dune expects all modules to be dependencies of that current model, so it looks around and where you find it. How do we solve it? We added browser-only PPX, and I'm going to explain now, on Switch platform. The idea of browser-only PPX is that you have a function, as I explained, like scrolls to ID, so it gets an element from the DOM and it scrolls to view, just moves the scroll position, and eventually the user is going to click it on an on-click event. This code doesn't make any sense on the server. The server doesn't know what the scroll is, doesn't know what DOM is, never's going to click, never's going to find anything, right? So this code lives on the client. What we implemented is what we call browser only. So you flag a function as a browser only, and we do some transformations on both. The two transformations are in modes melange. We keep the code as it is because JavaScript is expected like this. But on the server, we alert, we flag the function as browser only. And in case of somebody actually runs the function, we raise. So that's a runtime error. The other approach is like, okay, I want to not completely remove the functionality. I just want to have a different version, right? So another example that doesn't make any sense on the server, we want to calculate the banner size based on the actual DOM. So it's like get bounding client rec. How we do it is, again, you flag it with a switch platform, and then you pass the two targets, right? In the server, you always want 0. You don't care. That's the first load. And then eventually, for the two modes on one target, you compile the original code, and on native, you keep the 0. So then you can, like for little functions, for little values, you can have like the two implementations. There's other things that are cool about universal code is that these modules, they need to be bound, right? The biggest universal library that exists is Snarl library, right? Like Snarl library in OCaml is re-implemented in melange. For example, this is just the tiniest example ever. So you get an item from an array. In melange, it gets compiled as a file access. So at the end of the day, this is bound, but the idea is that just the JavaScript operator of accessing on an array. On OCaml, if you work down into the C runtime, at the end is similar. So it's field accessing on the array. So you have both implementations. That works out of the box because melange provides the standard library, and it's always compatible. There's one thing, one actually thingy, which is like on the top, the JavaScript is meant to run on the browser in this case. And that's actually C as well. So like at the end of the day, V8 or Chrome or JavaScript, whatever, JavaScript core and all of these implementations, they run C as well, right? That's just a fun fact. So going back to the beginning, this is a kind of a normal example on our code base. It's not a real example, but it's to demonstrate purposes. So you have like a component that gets a base and a path, creates a URL, and does something with it, right? So the first part that I want to look into is that this component depends on URL. So URL is something that it needs to get rendered. So URL is a module that depends on it, right? There's another case where you have regex. So does some matches on the regex. It's not a real syntax, but you get the point. And then, yeah, the regex and the PPX processor. And then it's required for the server. So if we ever run this component on the server, we need the output and the right behavior from both platforms, right? That's the challenge because we want to have URL and regex work the same behavior from both implementations, right? So just to go back, URL is a API provided by the browser, and it contains functionality like you create a URL and you can get the host name, get the path, and work with the URL, right? It's a very old API, but it's how the browser works with URLs, right? What we did is that we have an interface, right? You can create a URL, you can get a hostname, path name, and the entire API. The idea is in melange, you have FFI, so you bind to this API. So at the end of the day, the bundle has 0 additional cost. So we don't ship URL parser, we don't ship anything new, we just bind to the platform. On the backend, we re-implement, right? On the backend, we want the same functionality. We depend in this case of Mirage URI, and then we re-implement the same behavior on a different target, right? That's very simple, I would say. That's the easiest case to implement because dealing with the strings, with the URLs, is kind of a trivial task. There's something not so trivial about regexes. Regex is the ECMAScript version of the Perl PCRE implementation of regex. The idea is that you have like this syntax on JavaScript, and it runs the matching and what it's funny is that it contains a lot of features that are not part of the spec. So because ECMAScript, they run away from their thing. Like every implementation of the language implemented their own regex system. So there's a lot of features that other implementations do not have, right? This is like the actual syntax to create a regex, right? If you look around on OPAM, there's a lot of libraries that implement regex, and I was trying to use those, and of course none of them have the features that they wanted. So in this case, I could not re-implement it, right? I could not reuse something from OPAM and deal it. So none of them have all the features. Some of them have, some of them don't. And personally, I would never want to implement a regex engine. That was not my perfect summertime, actually. But then I started thinking, if I want to have regex on different platforms behaving the same, how do I ever do that, right? And then I realized that there's many JavaScript engines written in C and C++ out there, implemented, that pass the test, that are fully supported. And those are V8, JavaScript Core, Hermes, Chakra Core, Gal.js, and a completely long list of those. So JavaScript is obviously everywhere. And I got very interested in one, which is Quickjs. Quickjs is the smallest that I could find, so it's only one CF file. It's created by Fabrice Bellard. It's the FFmpeg guy, and he created half of the internet, actually. And the idea is that supports like the ECMAScript test suite. So to me, it was like very, very easy. I bind to the actual regex implementation, so I expose this API through OCaml. So at the end of the day, I'm running the same C code that the browser is actually doing, and it's tested by test suite. So I can ensure that any code works in the same way. This is a very nuclear kind of like a solution, and it's only useful when you cannot re-implement or it's not trivial. Those cases are probably regex, date, and local. Those are the three places where I'm probably going to use Quickjs. I would not bind everything. That would not make sense. The bad part is I'm bringing back JavaScript to the server, which was the initial goal I wanted to kill this, and I'm actually bringing a little bit of it. So I would consider myself as a Darth Vader if it was me. At the end of the day, we made the Ahrefs code base. I think 2,000 files were compatible with server-side rendering already. The rest are not needed for server-side. So I think we are almost fully compatible, and we could migrate like most of the pages very, very fast. The last thing that kind of I wanted to reflect on is we're creating all these tools that are universal, so I have like 2 targets and all of these. And it came the question every time that, are we creating a new ecosystem? Because every time they want to use a library that exists, I need to re-implement or it's already there. So we spend a lot of time recreating tools that were like already there. So yeah, getting into all the many pieces together, these are just a few examples. We needed to do CSS, JSON, asynchronicity, internationalization, and routing. So for every piece, I think we had like a trick. In this case, CSS, we used style PPX native. That's one of my projects that parses and type checks CSS. So I needed to just create another backend for it. On JSON was trivial because we use ATD and we have Melan JSON. So both are universal in that sense. Asynchronicity, there's promises that have the same system I explained before, where it binds to the promise API, and they have like a LWT bleach. In Azure, we use LWT, so that's kind of easy. For internationalization, we use a PPX that can handle both translation from front-end to back-end. For routing, we have the PPX driving router. So you define the routes in one file, and the router is type-safe from the 2 targets. And as well, like images, we need to figure out, standard library we need to figure out, data we need to figure out. So future work is very, very exciting. I have spent, I think, 6 months on it, and it's 7 components. 7 components are a way where the world lives on the server, and you don't render on the server and render on the client. You always render on the server, and there's tiny bits that render on the client. So you are in the OCaml world, and you only ship the part that are interactive to the browser. That makes the bundles way, way smaller. and makes like all the data fetching move back to the server. So on the Ahrefs case, that's the path that we're looking forward, because most of our job is to fetch data around. So if we move that data on the server, we're gonna have the collocation of data. The other work that we are spending a lot of time is some sort of a framework. Antonio mentioned that most front-end people are moving to Meta framework. We're trying to create our own. We are not very ambitious, but the idea to create these little routing paths, pages, and how you can define like a simple website in one single language, I think it's an appealing work. And the other one is just make sure that the universal code and the developer experience of it's on point, basically. So yeah, thank you very much.
Yeah, thank you, David. We're all really excited to have OCaml everywhere. Any questions to David?
Do you already have a way to manage the difference between a server-side and front-end side in case, for example, you are using a library on the server side that behave slightly different from the front-end sides, or you should take the right library from the start?
Right. So you're asking if you have a module that is implemented on the client, and
I mean something that the developer could say, okay, for example, for the date that you did not already implemented, the user can say, okay, I know the new date could work not exactly as in the client, so I maybe manage myself the exception.
yeah, so you could, so one of the, let me go back to a slide. You can see, for example, here that we raise this exception, right? There are a few cases on our code base that we have this. You wrap it in a browser only, and you can always try catch it at the end, right? Like you never want to raise in production, so if you are for sure that you have an implementation, you can try catch, and on the catch you do your implementation. For small modules, makes sense, but when you are re-implementing, for example, when you're implementing the good parts, sorry. When you're implementing URL, for example, that is a long API, it makes sense to create a different library, just to mimic the same interface. So, yeah, cannot find my own slides, but yeah. Yeah, in this case, it's better to have like two implementations, right? Like side by side. Imagine that you start with this and you end up creating one implementation. It's better to keep like same module name, but different from different targets.
Yeah.
I kind of have two questions. The first one is, do you have any learnings about the user experience of using this tooling? Have you, improved things over time? Is this the sort of like the initial design that you came up with? Do you have any thoughts on what you can actually improve in the future to sort of help people understand the trade-offs between, server-side, client-side implementations and so on? And the second question is, do you think you'll end up implementing a browser in OCaml? And if so, I guess it's exciting.
Let me answer the second first. So my dream is a big word, but my dream is to create a JavaScript engine. Make sure that you can throw JavaScript and then you have OCaml values. But yeah, I should not say that in public because I'm never gonna do it. But still, like that would be the like use Quickjs or use whatever, and all the bindings, like you only need to write the top one, right? And then you like the binding is just run C. The other question is like how we evolve with the design. We evolved a lot. Like the first implementation of browser PP, for example, browser PPX at the beginning didn't exist. People was using all the time like the Switch platform. And then we said, no, that's a hack. Like Switch platform everywhere is a hack. Sometimes you want to don't do anything. So we implemented the browser only. So you could flag with alerts. So alerts kind of propagate over functions. So you are very aware that, I cannot use that function. The compiler is telling me to not use the function. And then you're aware that you need to wrap it, re-implement it. Like you know that you need to do something. You cannot compile, you're going to ship the product. So there are a few developer experience iterations. One of the things that we cannot merge or like work is Dune context. Like the two targets need to live in different files because Merlin and LSP need to have different artifacts for both. Some people want to have like server-side code and client-side code in the same file. I found it personally weird, but I understand their motives, and that's a challenge. We have been working with Dune context and the Dune team, but at the end, the user experience was not worth it. So we are not using it on our repo. And there's like ongoing work, like the router that I show. It's a nice piece of code. We have as well a remote RPC call, so you can create the endpoints from the backend, and you can call it on the client as simple functions. Everything type safe. So these little improvements, we get them over time, and it's very similar what Antonio said, where we are shipping these as I started theoretically the project, but then as more fitting code, as more modules need to be compatible, we start finding use cases that we could not thought. So yeah, we battle tested real on every version. So it's, I don't know, version 20 of the initial project.
Thank you.
Thanks. Any other question? Perfect. Thank you very much.
Yeah.